This is a short lesson on energy which will be suitable for students of both Junior Cert and Leaving Cert Technology as well as Leaving Cert Engineering. So if we start off by looking at what is energy. Energy, and specifically renewable energy, comes from a source that is not depleted when used, such as wind or solar power. Now that is a very, very important distinction of renewable energy. So the source of that energy must not be destroyed or gotten rid of while the energy is being generated. So wind power, solar energy, wave and tidal energy, geothermal and biomass are all examples of renewable forms of energy. The first three are used a lot in Ireland. The last two are not as much, though biomass is a growing area within Ireland. So wind power, solar energy, wave and tidal energy are straightforward enough. Everybody knows what they are. Geothermal is where you pump water down into the ground, particularly where there are hotspots where magma is close to the surface. So this is used an awful lot in the likes of Iceland and places like that. And you pump down cold water, the magma, the hot rock, heats up the water to boiling point, that comes back up and that generates electricity. Biomass is where you are burning growing material. So for example, you grow forest, you then cut down the forest to burn it, and then you replant trees. So technically, biomass could be considered a renewable form of energy. However, as we'll see on the next slide, biomass is also considered a non-renewable form of energy because the tree you cut down is destroyed and a new tree is grown in its place. Now, non-renewable energy is specifically when we talk about natural resources or sources of energy, exists in a finite quantity. It cannot be replenished. So when you take oil out of the ground, when you dig coal out of the ground, it cannot be replaced. In Ireland, we are one of the few countries in the world that burn peat from bogs. Now that has actually changed recently, where there are no longer cutting peat or harvesting peat for energy generation. But you have fossil fuels. Nuclear energy is non-renewable. You cannot get more nuclear material to replace the material that's used up. And you have biomass again, as I've just explained. Now, we have lots of different forms of energy. You have mechanical energy. So this would be a moving machine or a moving mechanism. You have chemical energy. That's an obvious enough one from chemical reactions. You have electrical energy. You have heat energy from burning. You have light energy, which comes from the sun, amongst other sources. You have sound energy, so my voice is creating energy. And lastly, you have magnetic energy. Now, a lot of these can be used in combination for various different things, as we'll discover in other lessons. Now, we can't talk about energy without talking about one of the main topics at the moment, which is conservation of energy. So, the first law of thermodynamics states that the total energy of an isolated system is constant. Energy can be transformed from one form to another, but can neither be created nor destroyed. Now, this is really, really important because most of the modern world relies on converting energy from one form to another. So if we take, for example, a television. Television runs on electricity, and inside in the television, we convert electricity to both light to form the picture and sound so we can listen to whatever program we happen to be watching. In the speaker, we are directly converting electrical energy into sound. In a motor that's powered by electricity, we are converting electrical energy into mechanical energy to get the motor to spin. Now, continue looking at conservation of energy. We do have a limited supply of energy. The amount of energy that's available to any country or any person is not infinite. We have a limited supply. And the more energy we use, the quicker it gets used up and resources get used up. So conservation of energy has become a really, really important topic in the modern world. Now we can start off in design, where we look at using recycled materials, look at low impact materials, look at materials that use small amounts of energy in their manufacturing. So using recycled aluminium instead of new aluminium is much more energy conserving. And there are many different ways we can conserve energy in design as a result of this. Now, there are lots of different ways you can conserve energy in the home, for example. So in the home, we might switch to energy-saving light bulbs. We might replace an old washing machine with a new, more energy-efficient washing machine. For example, as two examples, in automotive systems, so in cars and things like that, we might replace a petrol or diesel engine with an electric car, which does use up less fossil fuels. Now, we have to talk about energy conservation, and this is where energy in one form gets converted into a different form. So kinetic, which is movement, gets converted into electrical. This happens in the likes of wind turbines and things like that. Solar to kinetic. Now, that is the experiment you see in the science lab, where you have the vanes with the black and white on each side of it, and when sunlight hits it, it causes it to spin. You have chemical to heat. That's basically burning. You burn coal, which is a chemical reaction which generates a huge amount of heat. You have kinetic to potential. That, for example, could be a spring in a clock or a spring in a wind-up toy car, where you apply kinetic energy by twisting the key, which stores the energy as potential energy in a spring. You have magnetic to kinetic. This is what takes place inside in an electrical motor, where electrical energy gets converted to magnetic energy, which causes the motor to spin. And then magnetic to electrical is what takes place inside in a dynamo, where a motor spins in a coil of wire in a magnetic field, which generates electrical energy. Now, let's talk about energy generation in Ireland. This graph here comes from this website, Ireland2050.ie, which I'll mention later. And this shows you the breakdown of energy generation in Ireland. Now, you can see here 45% of Ireland's energy comes from burning natural gas. Another 14% comes from burning coal. Another 9% comes from burning peat. So if you look at it, that is 45, 59, 68% of Ireland's electricity generation is coming from fossil fuels. So more than 50% is coming from fossil fuels. We have 18% coming from wind, but this is growing. The interconnector here is an important one. This is a connection that Ireland has to England. So we purchase roughly 8% of our energy from England. And then the two smallest sections up here are hydroelectric and other. Now, when you are looking at electricity in Ireland, the electricity coming into your home, it is measured in the kilowatt hour. So 1 kilowatt, 1000 watts used up in 1 hour is 1 unit of electricity. So if we take a 100 watt bulb, which would be an old style filament bulb, a 100 watt bulb is 0.1 of a kilowatt. So a 100 watt bulb in 10 hours will use up 1 kilowatt of electricity. Now, roughly at the moment in 2021, 24 cents per unit of electricity. So 1 kilowatt of electricity used in 1 hour will cost 24 cents. So this 100 watt bulb will use 2.4 cents per hour. Now, lastly, when we talk about electricity generation, under the other here would feature microgeneration. This would be where individuals have small energy generation systems at their homes or at their places of business. So a small wind turbine or things like that. And you see a lot of them around the place, where individuals where individuals create their own electricity. Now, we have to talk about efficiency because this is really important. This is another area of conservation. The efficiency of any system is what energy do you get out compared to the energy you put into it. Now, the second law of thermodynamics, you can never have 100% efficiency. Efficiency will always be less than 100%. If a system was 100% efficient, you are basically breaking the laws of physics. So efficiency will always be less than 100%. Now we have an example here. An electrical motor is powered by 240 volts. The current it's drawing is 12 amps. And when we measure the output of the machine, we are measuring 2,400 watts. So we want to find out what is the efficiency of that machine. Well, to first of all, input power in watts is voltage multiplied by current. So 240 by 12, that gives us an energy input of 2,880 watts. So if we run through our equation here, 2,400 over 2,880, and our efficiency is 83%. Now this is important. We want to try and get that number as large as possible. Now I suppose the question there is, where is that energy lost to? Well, in a motor, you're going to have some energy lost during the actual conversion process from electrical energy to mechanical energy. Motors make noise, so some of that energy will be given off as sound. Some of the energy will be given off as heat. You're going to have friction from all the moving parts, so some of the energy is going to be lost that way. So 17% of the energy is lost due to all of those various factors combined. Now, if we have a look at examples here of efficiencies, a coal burning power station is only 35% efficient. So what that means is the potential energy in the coal, only 35% of it actually gets output as electricity. The rest of it is lost during various energy conservation processes. In wind farm, it's slightly better, it's 40%. Hydroelectric is one of the best, it's at 80% efficiency. So 80% of the potential energy in the water is converted into electrical energy. And you can see down there, just put this in, a bicycle is 90% efficient. So 90% of the energy you put into a bicycle when you're cycling gets converted into usable energy. Now, encouraging energy efficiency. A BER cert is now a legal requirement if you are buying or selling a home, and this relates to the energy performance of your home. The BER cert is similar to those colour charts you see on household utilities, so the likes of washing machines and dishwashers when you buy them brand new. That is in essence what a BER cert actually is. SEAI, Sustainable Energy Association of Ireland, is Ireland's Sustainable Energy Authority. This is the body that regulates and looks after all of these kind of energy areas. Now you can go to the SEA site to view what they do. If you go to Ireland2050.ie, this is a website of the Energy Institute, which is a registered charity in England. It's also a professional organisation, and they specialise in energy-related issues, and they have links with all of the relevant associations and organisations in Ireland, such as the Department of Energy, the ESB, and Bord Gáis, all these other groups. And if you want to learn more about electricity generation in Ireland, you can go directly to the ESB website. Now, if you get a BER cert, this is what it looks like. And you can see here, you have your colour-coded chart. The higher up it is, A, B, C, the more energy efficient your house is. Now, what they mean by energy efficient is the higher up you are here, the less CO2, carbon dioxide emissions, are needed to keep your house warm and functional. Now, there's a lot of other information here, and you can find all this information on the SEAI website. Next, and this is the last thing we're going to look at, is energy conservation within transport. So, particularly if we look at cars, buses and trucks all operate at the moment on petrol and diesel, but you also have the option of biofuels. Some countries around the world have moved into biofuels in a large way. As far as I know, Brazil, now all public transport vehicles operate on biofuels. You have electric powered cars and you have hybrid. Now, hybrid seems to be the big area at the moment, the big growth area, where you have plug-in hybrid and you have dual power hybrid. So a plug-in hybrid car combines the best features of a petrol and diesel car with an electric car. A plug-in hybrid car, you can plug it in at home to charge up the batteries, start driving on electric. But if the batteries start to run a bit low, or you start doing some heavier driving such as on a motorway, it also contains a small petrol or diesel engine which kicks in to provide extra power for recharging the batteries or running the engine, running the car better on at motorway speeds. And hybrid seems to be the preferred option. The best option seems to be the plug-in hybrid, so that you can plug your car in to power it, and it's using the petrol or diesel engines as little as possible. Don't go for just a pure hybrid that is not plug-in. The self-power hybrids, because that relies on the petrol and diesel engines to charge up the batteries. And for short drives, you would be using the petrol and the diesel a lot. The plug-in hybrid would be the best option. There is a target in Ireland to have 1 million electric cars on the road by 2030, but there is a lot of controversy as to whether this is viable, and a lot of that controversy comes from the fact that electric cars and hybrid cars, brand new cars, are still quite expensive, and a lot of people simply can't afford to trade in their petrol or diesel cars to go to a brand new electric car. There's also the issue of batteries in electric cars typically are only rated for 5 to 7 years. After 5 to 7 years, the batteries may need to be replaced, and at that point it is a very expensive option. You could be looking at thousands of euro to replace batteries in a car. So there is still a lot of work to do in this particular area. That's it for energy and energy conservation. Hopefully you found this video useful.